Hey everyone, welcome to the channel. My name is Nader. In this video, we're going to go over a bunch of exercises together to practice recursion. Recursion, as we saw in the previous video, is quite a gnarly concept. So I made quite a lot of exercises for us to go through just to get more practice, since really with this topic, the only way to get good at it is to constantly practice different recursive examples and then actually write down using console logs and on paper the way that things work. So we're going to kind of go with as much examples as we can. We'll do some console logging and see how these work. I've structured this set of exercises to go through kind of a warm-up exercise to get our fingers warmed up, then a easier quote-unquote exercise, followed by two quite challenging exercises, and then finally a totally crazy bonus exercise. But the point of these exercises, especially the intermediate and the bonus exercise, is to really kind of see how practically we can see recursion, because a lot of the time when you're practicing recursion or you see examples or study it, for example, it just doesn't seem like very useful until you actually start to see real world applications of recursion, which we'll actually get into a couple of those in these exercises. Now, before we start, I do want to mention that these, even the easier ones, are quite challenging. This is definitely like an intermediate / advanced topic when it comes to programming and JavaScript in general. So don't really fret too much while you're going through these. Just do your best. You might need to watch this a few times. I would really be surprised if someone was able to just kind of crush every single one of these kind of in one go or one sitting without much practice kind of beforehand, or really even knowing at least at a beginner / advanced level how to work with recursion. So that said, let's just get right into these so that we can get more practice together. Okay. So as with all the other videos, the way that I've structured these is I have a bunch of files kind of pre-prepared, and these are all in the GitHub repo for this set of exercises. So if you don't really want to copy and paste, or you don't want to like retype these out all, you just want to kind of copy and paste it from one place, or you just want to download it all, feel free to check out the GitHub link in the description. All of this is in there. I might even include some of the actual testing examples that we go through in there, just so it makes it easier, so you don't have to think about too many examples to test, since I actually thought of a couple of interesting cases to work with for some of these. So check that out if you don't want to type these out, especially for the bonus, which I'll mention later. So for this warm-up, what we want to do is kind of a rehash of the typical FizzBuzz function. I believe we did this before when we looked at loops. This is kind of the stereotypical beginner interview question, but we're going to tackle it with recursion. Now, just kind of as an aside, if someone gives you this question in an interview and you tackle it with recursion, I think you probably get quite a lot of bonus props from that right away. Most of the time, the real intention of this is really just to use loops for FizzBuzz in general. So if you kind of come in there and you're just like, oh my gosh, this is too easy, I'm just gonna go full out this thing with recursion, I'm pretty sure they would be quite impressed, as long as you can also solve it with loops. Okay, so what is this FizzBuzz thing all about? Well, we're gonna do a bit of a twist on it. So this function, we're going to call it FizzBuzz, is going to take two number arguments. Okay, it's going to take a start num and an end num. All right, so we're going to call FizzBuzz. We're going to give it these two numbers. The function is going to count from start num up to, or let's say including end num, and it's going to be incrementing by 1 each time. So for example, if we give it like 10 and 20, it's going to go like 10, 11, 12, all the way to 20. Right, up by 1 each time. We could give it like 10 and 100 or 30 and 100 or whatever numbers we want, and it should work with every single set of numbers. So the way that this FizzBuzz works is very similar to how we saw it previously. If the number that we're looking at right now, as we're looping through this or recursing through this in this case, is divisible by 3, we want to print fizz. If it's divisible by 5, we want to print buzz. And in this case, we want to also follow it by the number, just so that we can see that we're doing this correctly as we go along. But if it's both divisible by 3 and 5, we want to print FizzBuzz followed by the number. So the most important thing here, I should mention, in all other cases, we just want to print the number itself. So if it's none of these cases, then just print the number, like if it was 11, for example. But the most important thing is we don't want to be printing like fizz or buzz and then also FizzBuzz. So it should be mutually exclusive for these three cases. In fact, it should be mutually exclusive for all these cases. So it's only going to be one of these cases at a time. It can't actually match two of these cases because we should only be printing one thing at a time per number. All right, so the twist for this one, this is the recursion video. So you must solve this using recursion. If you've never seen FizzBuzz before, I would encourage you maybe just to start like solving this with loops and see if you can kind of get that working. That should be pretty quick. And then once you have that and you know the basic idea of how that works, then you can test it with recursion and see if you can get that working and really start testing this with different start and end values to make sure your actual cases work correctly. So before I dive into this, I just want to give you a hint. What you want to think when you're thinking of recursion in general, but also this example, is what's kind of the base case, right? So when we looked at recursion, we have to have kind of an exit to this recursive loop, basically. We need a way to return out of it so that we stop recursing and we can kind of unwind this loop. So what's the difference in this case with this FizzBuzz example between the base case where we just return out and we can stop the recursion, and then the regular cases, which hint are kind of these ones right here. So give that a shot yourself and then pause the video. And then once you're done, let's come back here together and take a stab at it. All right, so let's start here. So let's create our function. I have my notes here on my other screen just so that I don't make too many mistakes with all of you, because doing recursion off the top of my head I can do most of the time, but I want to focus on the actual explanation. So we have start num and we have end num, and that is the way that our function works. So for example, we want to be able to call FizzBuzz with our number, for example, like 1 to 10. Right. In fact, I should probably do like 1 to 20 because I want 15 in there to really show that we actually are handling with that case correctly. I'll do this with more numbers later on, just so that we can actually see how this works with any number of numbers. Okay, so we need to think. Let's kind of just start with the fact of that we need to figure out what to do in the regular FizzBuzz cases. So let's pretend that we're going to be testing start num, because what I want to do is every single time we iterate through this recursion, I want to be able to actually increase the start num by 1 until it reaches all the way up to the end num, and then I can stop. Okay, so that's giving me a hint as to what we'll look at later, which is the base case. But let's just deal with these cases first. So we'll say if the, so I'm actually going to kind of solve this a bit quicker than I normally would, just because we've seen FizzBuzz before. I'm going to start with the 3 and 5 case. So I'm going to say if start num, I can do this by 15, but I'll just do it explicitly, is evenly divisible by 3, and start num is evenly divisible by 5. Then we're in the 15 case, so we can do a console.log. I'll use a template string here, and I'll say FizzBuzz, and then I'll put the actual number. So like we mentioned, we're going to be using start num as that number. Okay, then let's do the 3 case, so else if start num mod 3 is equal to 0. So just to be super clear, this is mod 15 technically, right? This is evenly divisible by 3. Then we want to just put a console, just copy that there. This is going to be fizz, and I'll say else if start num is evenly divisible by 5. Okay, lots of cases to deal with here. Then what we want to do is do buzz. And in all other cases, so for not 15, not 3, and not 5, then we just want to print out the number directly. So I'll just kind of just grab them. I don't have to do template string technically for this, but I'll just go with that. All right, so my prettier took control there and formatted my code for me, but that's pretty good. So this is effectively these cases right here. Okay, we kind of skipped ahead. We thought of the not base cases. So this is just regular FizzBuzz. But you might notice here that this looks kind of weird, right? Because we're not really ever increasing start num. We're not really using start num or end num anywhere. So what is this all about? Well, what we really want to do is at the end of this function, we want to start the recursion. So if I call FizzBuzz with 1 and 20, Start num is going to be 1, end num is going to be 20. I want to then be able to go up to 2, and then 3, and then 4, and then eventually I'm going to end at 20, right? So I want to then call FizzBuzz again, but I want to take the start num and I want to add 1 to it, right? So then it'll go from 1 right here to 2 right here, and then 3, and then 4, etc. And the end num is actually going to remain the same. We're not going to change that at all, okay? So we don't want to manipulate the end num. That's just so that we can give it different starting values. Now, if we run this right now, what we'll get is an infinite loop. Okay, so let me show that to you. So if I pull up my terminal here and I run node warmup exercise, you'll see that we get this crazy thing where our node eventually, until I stop it at least with a control C, it managed to get all the way almost to 10,000 with our FizzBuzzes. So I guess we can see, are we correct here? I have a FizzBuzz, is that by 15? I don't really want to do the math right now, but let's just assume that maybe we're doing this correctly. Okay, so all right, so that's fine. I'll clear that out. But now how do we stop this infinite loop, right? This is really the tricky part of recursion. The tricky part of recursion is trying to figure out what are we going to be changing every single time, very similar to the loop example of, incrementing I by 1, for example. But then also, when do we stop? When do we actually exit out of the recursion? In this case, we want to stop when the start num is equal to the end num, right? That's effectively, if we say, for example, when we eventually, this number becomes 20, which is the end number, then we want to stop, right? So I'm going to say if the start number is exactly equal to the end number, then I want to stop. So how do I stop? Well, in a function, we can stop calling functions and return out of a function using the return keyword. And that's how we break out of a recursive loop using the base case, okay? So this is our base case right here. So now if I run this, what we'll see is, yeah, that should be visible there. We're going all the way from 1 almost to 20, so I can do something here to change that a little bit, but this looks correct, right? So 3, 5, yeah, buzz, fizz, fizz, buzz, fizz, fizz, buzz. Yeah, okay, looks good, looks pretty good, right? And if I want to make this go all the way to 20 inclusive of the end number, I would say if the start num is equal to the end number plus 1, that's kind of one way we can do this. So if I rerun this, we'll see that now I go all the way to 20 and I get my buzz printed out, which is fantastic. So just to really show you how cool this is, if I go all the way up to, like, let's say 100 here, now this will get cut off by my face, but if I run this, actually it doesn't get cut off, I guess. You can see that all of these numbers are coming through, which is pretty awesome, right? Now, this is an example of recursion. Now, is this the best way to use recursion? Definitely not. In fact, this is actually quite terrible. This is a really terrible way to use recursion because we're actually using stack frames, which is effectively memory. We're adding more and more and more memory every single one of these function calls, instead of a loop, which actually only needs to keep track of a counter, for example, right? So these function calls are not free. They do take a bunch of resources in our memory, and eventually we'll run out of them and we'll have a stack overflow with our function calls. So there are cases like this where this is not a good idea and it would be better to solve this with loops. However, many cases that lend themselves to recursion usually are very tricky to solve with loops, and we'll look at a couple in this video next. So hopefully you can see that, but for now, don't worry too much about the memory stuff. Just focus on actually making sure you understand recursion before we can actually go to the more advanced topics of looking at things like the stack frames and the memory layout when we look at how the actual recursion unwinds and then increases the memory size. Okay, so let's take a look at exercise 1. Okie dokes. So similarly, this one is the quote unquote easier one that I've made for us. And I want to say easy in quotes for you because it really, I don't want you to think like, oh my gosh, he said this is easy. I should be able to do this, right? Definitely not. This is not a trivial set of challenges to do. This recursion in general is very complicated. Like I mentioned in the previous video, when I was learning this, I went into the lab to practice this stuff, and I was more confused coming out of the lab than I was going in, right? So it just takes some time, it takes some practice, it takes an appreciation for what it's doing and how it differs from other techniques. Eventually you'll get it, but just practice and keep going. So for this one, we want to go through a palindrome example. This is another typical kind of interview one that you will get. Definitely not an ideal case for recursion. However, we can apply recursion to this, very similar to FizzBuzz, just so that we can get a bit more warmed up and comfortable with a more complex example before we go to things that are very hard to solve without recursion in the next 3 examples. Okay, so for this one, we want to create a function called palindrome. Okay, and this is going to take a single string as an argument. The function is going to return true if the string is a palindrome, which I'll show you in a second, or false if it's not a palindrome. Okay, a string is a palindrome if it reads the same from start to end as it does from the end to the start. Okay, so what does that mean? So if we look at some examples of valid palindromes here, so these would all return true. Race car. This is a palindrome, right? Because R-A-C-E-C-A-R. If we look at those letters front to back, it's the same as back to front. So R-A-C-E-C-A-R, right? That's a palindrome. L-E-V-E-L, L-E-V-E-L backwards too. M-O-M, M-O-M, kayak, front and back, right? So these are all examples of palindromes, and we'll put some examples of not palindromes, but pretty much most strings are not palindromes, as you can imagine. So the trick here is to solve this using recursion again instead of loops. Traditionally, you probably would solve this using a loop. You could maybe have something starting at the beginning character, something starting at the end character, and then kind of tracking it inwards. However, with recursion, we can add an extra twist and see how this actually works, just so we can get a bit more practice with it. Now, for this one, I do want to give you a hint, just so you can start somewhere when you're thinking about how to solve this problem. What are the base cases? Okay, like fundamentally, if you were to start writing down strings, right, at a very basic level, the smallest possible strings, right, like 0, 1, 2, 3 characters long, right, at what point can you tell that something is a palindrome or not at that level, and what should it return, true or false, right? And is that a valid base case? So we can actually stop our recursive loop. So eventually we can break down a bigger problem into smaller and smaller subproblems. So I came up with, I believe, 4 for this one. I think that's most of the solution. Maybe there's other methods, but just to give you an idea of how many I came up with there. So give that a shot, definitely a challenging one, and then we'll go through it together. Okay, so I'm going to create this function. I'm going to call it const palindrome. This is going to take a string, and we're going to do something with that string. So on my other monitor over here, I have a bunch of test cases. I normally don't copy and paste, but I'll copy and paste them in here just so we can look at what this will be for test cases. Okay, so I have a bunch of test cases here, and you can come up with your own. I have the ones that should return true, and I have the ones that should return false. Okay, so when I run this code, I want to be able to test it against these cases to make sure I get the correct answer. Now, let's think about these base cases. So in the most simple example, what is the simplest possible string? Well, the simplest possible string is a string that has no characters in it, an empty string, right? So if I call palindrome with an empty string, should I return true or false? Let's just arbitrarily say true. Okay, so if I say string.length, if that is equal to 0, then we want to return true, right? So let's just say an empty string is a palindrome. Okay, so what are some other base cases? Well, what about a single letter, right? Can we immediately tell if a single letter is a palindrome or not? Yeah, we can, right? So if the string.length is equal to 1, then is this a palindrome or not? So is the letter A a palindrome? Well, yeah, because it's technically back to front, front to back is the same, right? So we want to return true. Okay, next, what if we have a string that's 2 characters long, like AB, right? Is that possible to immediately tell if it's a palindrome kind of like in one step, quote unquote? Well, yeah, we can, right? Because we can check to see if the 2 are the same, then it's a palindrome, right? But if the 2 are different, then it's not a palindrome. Those are the only possible cases, right? Are they the same letter or are they different letters if it's a length of 2, right? So if string.length is equal to 2, then we want to, actually in this case, I should probably say, we want to do 2 checks, right? We want to check if the first letter is the same as the second letter, right? So we want to say if str at 0 is equal to str at 1, right? Then we want to return true. I'm doing this all in one line. I'm not doing extra curly brackets. Otherwise, we want to return false. So I can eliminate the else in this case because this is only returning true or false. Now, I want to show you kind of a neat thing that we can do in these cases. Whenever you see something that's either returning true or false based on a condition like that, technically speaking, what we can do is this. I don't want to confuse you more, but I want to compact this code so we can kind of really see what's happening without too much nesting and brackets in here. So what we're asking is the first letter the same as the second letter? If you think about this comparison itself is going to return true and false. True or false, I should say, right? If they're the same, it's going to return true. If they're different, it's going to return false. Okay, so what we can actually do instead of doing this whole return true, return false thing is I can get rid of all this, get rid of this, and I can actually return this expression directly, right? So this is saying check the first letter, check the second letter. Are they the same? Yes, return true. Are they different? No? Okay, return false, right? Hopefully that makes sense. Okay, so the next thing we need to figure out is what happens if we can check the letters and immediately tell if it's a palindrome or not. Like if you think about looking at two letters, over here, what we have is when the string gets chopped down to a length of 2, then we can tell if it's palindrome or not pretty easily. But what if I give you a really long string like this? If I give you a string, let's say like race card, like this right here, in one step, without actually going to the inner letters, just looking at the outer letters, are you able to tell if this is a palindrome or not? Well, yes, right? Because if R and D are different, which they are, right? Then it's not a palindrome because it's not going to possibly read the same from the front to the back. So we can actually also add a case where if the first letter and the last letter that we're looking at currently are different, then we know we're not in a palindrome. So this is kind of our failure case. We're going to fail the test if as we're chopping down this string, the kind of outer letters, the first and the last letter, are different from each other, right? In that case, we know that it's not a palindrome. We don't even have to continue checking inwards. We can immediately return false. So how do we put that in code? So we can say if the string at the first letter is not equal to the string at the last letter. So how do we get the last letter's index? Well, that's going to be the string dot length minus 1, right? That's the index of the last letter. And I can say return false if this is the case, right? So in the case of race card, for example, right, or D race car, we would immediately be able to return false in one step because we would not meet any of these conditions, but we would immediately meet this condition and we could return false in just one step. We wouldn't even have to recurse further into the string. Okay, so the next thing we need to do is we're going to take this string, and if we know that the two outer letters are the same, what do we need to do as a next step? Well, we need to keep chunking away at the string going inwards, right? So we can take off the last two letters and then look at the rest of the string. So if you think about race car, we're going to get rid of R, we're going to get rid of this R, and then we're going to look at ace ka, right? The first or the index 1 all the way to index 2, 3, 4, 5, right? Or yeah, 1, 2, 3, 4, 5. So if we have that letter, then if you think about it, now we're looking at the last two again, and A are the same, right? So we continue kind of this recursive loop. But if A and A were not the same, if it was like A and E or something, then we could exit out, right? So our goal is to continue chopping off letters off the end of the string from both sides until we get to one of these base cases. All right, so let's code this. I'm going to return calling palindrome. So what we really want to do is get a substring. So let me kind of pull up Google real quick, and I'm going to say string substring in JS. String.prototype substring, that sounds right. We're going to look at prototypes in a future video. So if I say string.substring for Mozilla 1, 2, 3, that's from here to there. Yeah, that's great. Okay, so index start, index end, and let's see this index end. So it doesn't include index end, 0, 1, 2, 3. Yeah, so it's up to the end minus 1 effectively. Okay, so what we want to do here is we want to call string.substring. And we're going to call our palindrome with the substring because we've already solved for all of the base cases. And we want to chop off the first letter and chop off the last letter. So I'm going to say we want to go from index 1 up until the string.length minus 1 because we want to exclude the last element, right? So it's up to the index minus 1 is the last element, and substring is not going to include that index in the substring. Okay, so if we do this, funnily enough, we're actually done, right? That's actually the whole solution, right? That's the kind of beauty of recursion. We can actually write out these base cases, and if we solve for the smaller cases, as long as we figure out how to recurse, we've solved for every other case as well. So let's check this out. I'm going to pull up Node. I'm going to say exercise-1, and look at that. All right, that's pretty cool, right? I get true, true. I get false, 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 and then true, true. So that's pretty good. That's pretty amazing, right? Now, I understand that looking at this code, you're just like, oh my gosh, Nader, like why would you do this, right? Why would you kind of torture us with a recursive example palindrome? I know how to do this with loops, right? And the point of this is to really understand recursion, because the more that you can practice turning loops into recursion, or even the other way around, the better you get at these concepts. Okay, now I want to start getting to the trickier and actually practical use cases for recursion. These have mainly been toy examples, things that we could have solved with loops, but mainly to get us warmed up. What we really want to see is where this is used in the real world. So that leads us to our next couple of exercises. Okie dokes. So exercise 2. We want to create an array flattening function. So let's see how we're going to do this. We're going to create a function called flatten. This is going to take a single array as an argument. Then the function is going to return a flattened version of the array no matter how nested that array is. Okay, and we have to solve this using recursion. So I have some examples of what that means here. So if I give it an array that has no nesting in it, then it's going to give me back a regular array, which is fine. If I give an array like this array right here, you can see that I have an array of numbers, but the last element is also an array of numbers. Okay, which is totally valid in JavaScript. I want to flatten this out so that I get this array right here, just one level with no nested arrays. Okay. Same thing here, right? A more complicated example. Lots of nesting going on in here. You can see that I get it back out in the same order, but unnested. Okay, now you're probably looking at this and being like, oh my goodness, right? What is happening and how is this even possible, right? That is usually the reaction when you're looking at something that probably needs something like recursion or some of these more advanced tools to solve. Because if we can solve the base cases, usually what we can do is expand that to solve the more complicated cases, no matter how complex those may seem. So here are some tips for you. You're probably going to want to look up how to check if something is an array in JS on Google or MDN or something like that. Okay, we need to figure out how to tell if we're looking at an array. And we also want to figure out what are the base cases and what do we return in those base cases. Okay. Now this is extremely challenging. So give it a shot, do your best, and then we'll take a look at it together when you're done. All right. So I'm going to create a flatten function here. And this is going to take an array. I'll just call it ARR. And to kind of pull in some examples, I'm just going to pull this from my other screen over here. I have a whole bunch of examples of using this, right? So we're going to test it against this and we can see if we get it flattened out. All right. I'll put this in the repo as well if you need it to copy from. So how do we actually get this flatten working? Like, where do you even begin with this? So I'm going to propose a start. I want to see if we can build up an array over time, that's going to be our flattened array. Okay, so we're going to start with it empty, and we're going to keep adding to it as we progress through each item in this array and hope that eventually it'll be filled with the correct items. So I'm going to say const result is equal to an empty array, and then I'm just going to return that result, return the result. Okay, now we need to figure out how to actually add stuff to this array. Okay, so let's think about this. In the case of a simple example like this, where we have an array of numbers, right, with no nesting, what would we do? Well, we would want to loop through every item, right, and add that item to this array of a result, right? But we, in this case, know that maybe not everything is a number, but let's just for now pretend that's a number. So let's create that loop. I'm going to say for const element of array. I'm going to just push that onto the array, right? I'm going to say result.push, and I'm going to push the element, and now I have that on the array. So if you think about this right here, we've solved for 35, right? My line 35 right here. This would actually work, right? So let's run this and take a look. So I'm going to run node. I'm going to say exercise 2. Okay, well, these other ones, you can see there's some funny business going on in there. Definitely not what we want. But this first one is actually working. We're getting our 1, 2, 3. Okay, so far so good. Now we need to think about, okay, well, this works until we see an array, right? So if we see an array, well, what do we need to do? Well, we want to do the same thing, right? We want to loop through the array and add each item in that array to our result. Okay, so let's think about this. How can we tell if something is an array or not? So that's where this Googling comes in. So I'm going to pull up Google. I'm going to say how to tell if something is an array in JS. All right, so looks like we have some things here. Everything looks to be pointing towards this is array thing. Array is array, static method determines whether the pass value is an array. Perfect. So array is an array, we give it the thing, and it's going to return true if it's an array, otherwise false. Okay, wonderful. So let's try this out. So we're going to say, if the element that I'm looking at right now is an array, array.isArray of the element. That means that we're looking at an array, right? So looking at an array, right? What do we want to do for this? Well, technically what we know is that if this entire thing is an array, I can actually pass it to my flatten function because I know my flatten function is built to flatten out an array, right? Because maybe, just maybe, one of those items in the array is also an array. Okay? So let's just call our flatten function and let's give it our element. Now I want to store this somewhere so I can kind of have that result to do something with it. So I'm going to say const flattened is equal to flattening this inner array element. Okay. And then in the case of else, we're going to have this case right here, where if it's not an array that we're looking at, then it's just a thing that we can push to the array directly. So we can deal with, we've already dealt with that case. We already know how that works. The trick here is this case. If we're looking at an array, well, what do we need to do? Well, we want to loop through every element and then add each of those elements to result and then return the result. Okay, so eventually what we're going to get is this flattened is going to be the return value of calling flatten on an array. And if we're returning an array, then we're going to have an array here. There's a lot of array. Okay, so we're going to want to loop through this array because we know that it's been flattened and then add each item to this result. So I'm going to say for const inner element of flattened, right? I want to result.push, and I'm going to push that inner element. Okay. Now, this is the most confusing part of this solution. Okay. We have a loop, but then we have another loop. So what on earth is happening? The only way to really work through this is to trace the code and see that we're going to get back an array inside of flattened. And that's going to be an array of the flattened elements inside of this element. Once we have that, we can add them one at a time to our result out here before we continue to the next items. So for example, we're going to look at 1, we're going to push it to result. Look at 2, push it to result. Look at 3, push it to result. That's all the else case. When we get to 1, 2, 3, we're going to enter this if case right here. Okay, that is an array. So we're going to call flatten with this 1, 2, 3 array, right? And now we're ending up where we were before in the same case as what we were just looking at, right? We're going to have 1, 2, 3 come in. We're going to loop through it. We're going to add 1, 2, 3 to the array, and then we're going to return result. So this is actually going to be flattened is going to be 1, 2, 3 if we call it in the case of this example right here. So we're going to loop through 1, 2, and 3, add each of them to this array, which already has 1, 2, and 3 in it from previously, which is these ones, and we will get the full version of it. Okay, so that's actually the solution, right? Again, this is the crazy thing about recursion. Because we've solved for the cases where it's an array and it's not an array, right? We've actually found the whole solution. Okay, so let's take a look at this. So look at this example here, and then let's look at the flattened version. All right, there we go, right? That's pretty amazing. That's the solution, right? 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3 again, because I switched kind of the order of these. And then we have these more complicated ones with more deeper nesting. Okay, now very, very tricky example. Definitely will take some actual reading through and logging as we go. I just want to clean this up a little bit because technically what we can do here is if you don't really like this loop, what we can do is we can get rid of it, because what we can do with push is we can say result.push. Push actually takes any number of arguments and it's going to add them one at a time. So I can actually use the spread operator, which we learned previously, and I can spread out flattened into here. And this is actually going to add them all. This is the equivalent of pushing them one at a time. Okay, so this is actually going to call push with like the first item, and then push with the second item, or actually in this case, I should probably say this is going to do push 1, 2, 3, just like that. Right? So we're actually doing, in the case of this one right here, specifically 1, 2, and 3, we're doing result.push 1, 2, 3, and push is built so that if you give it multiple arguments like this, it will actually just loop through them internally, basically doing exactly this. Okay, so if we do this, we'll actually get the exact same solution, and there we go, if you don't like that loop. Okay, now this is pretty amazing. Very complex example, but a very good demonstration of how powerful recursion is. Like if you look at this code, right? There is not much code in here to flatten an array of any level of nesting. This is pretty complex over here, right? We can have any level of complexity here. And as long as we figure out the base cases and we solve for the smaller cases, and we figure out what the recursion actually is, we end up with this beautiful set of code. Technically, if you really wanted to get fancy, you can actually get rid of this one right here and put it directly here as well and get rid of even one more line of code. Okay, now I hope that that one was informative enough. Definitely trace it through and actually either write it on paper or put some logs in there. Let's take a look at example 3. Okie dokes, so this one, similar example, however, this time we're gonna work with objects. So I want you to create a function called flatten that's going to take an object as an argument. The function is going to return a flattened version of the object no matter the nesting inside of that object. The only trick here is that if there are keys that happen to clash with each other, it's going to get overwritten by the future keys. Okay, so if we have like an ID as you see here, if I didn't have ID 2, ID would get overwritten by the second ID. Okay, But just for sake of example, we're going to go with this just so that we can see how it works and how amazing of a set of code we can write, very similar to our array example. You want to solve this using recursion, and it would look like this, right? If we call flatten with an object that looks like this, what we would get is this flattened version. So you can see in here, we have an object, and inside of that object, we have ID, name, and happy, right? But we also have friend, and friend itself is an object, which has ID 2, name 2, and happy 2. I should probably indent this over a little bit so it's a bit more clear, right? These key values are going to get flattened out into the top level of this object, so that we have this resulting object with everything on one level with no nesting, and this friend has been eliminated. Okay, so definitely a tricky one. Here is some hints for you. Here are some hints. You're going to want to use a type of operator to check if something is an object. Now, don't get too caught up by this part. It's really, really important that you don't spend all your time trying to figure out how to build something to check if something's an object or not. Honestly, build a naive solution, because the point of this is not that. The point of this is to solve the recursive flattening, not to build a function to figure out in all cases is something an object. Okay, so a simple type of operator to test if something's an object is good enough for this. Don't go too crazy with that. Secondly, the delete operator allows you to delete a key from an object, which we saw in the objects video, if you need a recap on that, or you can Google it as well. So give that a shot, lots of Googling, try to think of the base cases, try to think of the recursive case, go through it, and then we'll go through an example or a possible solution together. All right, so let's start building this out. I'm going to create my flatten down here. So again, this is in the repository for GitHub, so either copy and paste it off of there or download it using Git, and that should be easy to follow along. I'm going to create my flatten. It's going to take an object. And in this case, I'm just going to copy a whole bunch of examples that I have over here with some pretty complex objects, just so you can see. I kind of got lazy with my naming, I guess, here. Some strange names for my object keys here, just to really test that this works with levels of nesting. And we'll test this out with our flatten shortly. So now let's actually build this. So similar to our array, right? What do we want to do? Well, the way to think about this is I want to go through every key and value in my object and kind of make sure that it's at the top level. So the easiest way to do this is to create a new object and just start adding keys and values to it, but making sure none of those are ever nested. Okay, so I'm going to say let result. I'm going to use let here for a second just to make it easier on myself later, which you'll see shortly. I'm going to return the result. Okay, that's my step one. I'm going to create a copy. I'm going to start doing stuff with it, and then I'm going to return it. Now, what do I want to do next? Well, I want to loop through the keys and values inside of this object. So I'm going to create a for of loop here. I'm going to say for const. I'm going to use destructuring here to make this a bit easier. Key value, which we saw in the destructuring video. Object.entries of object. Okay. So in this case, I'm going to be able to look at the key. I'm going to be able to look at the value. So for example, I'm going to look at ID. I'm going to look at 1. I'm going to look at name. I'm going to look at Bob, happy, and true. So what am I asking? Right? What's the question that I need to figure out? Well, the key doesn't really matter, right? If you think about it. So I guess it matters to some degree. We need to delete it and do some other things. But it's a value that really matters. We want to ask the question, is the value an object? That's what we're really asking, because we're trying to unnest this object, right? So for now, just like the array example, let's try to figure out what happens if it's not an object. The very basic case of an object like this with no nesting whatsoever. What do we do if we know that there's no nesting? Well, we just add the key and the value to this object. So we're going to say result at the key is equal to the value. Right? Pretty simple. So let's test this out. I'm going to run node. I'm going to run exercise 3. And right here, we can see that I have the correct thing. These are also technically correct, but we can ignore those for now because that's not actually what we're doing. They're just recreating the object, but not deep copies. So we have ID1, name Bob, and happy true. Okay, wonderful. So that works for the case of not an object. So what happens in the case of if we do have an object? Well, now we need to figure out in JavaScript, how do we ask if something is an object or not? So let's go to Google. I'm going to say JavaScript, how to check if something is an object. Okay, check if a value is an object in JavaScript, Stack Overflow. Is there anything on MDN? I don't see anything. Okay, let's go Stack Overflow. I'm going to zoom in a little bit here. If the type of your variable is equal to an object, it's an object or null. Okay, I mean, that seems easy enough. There's a whole bunch of fancy stuff we can do over here, but this seems great. So let's just go with that. If the thing isn't, if the type is an object, then it's an object. Otherwise, it's null. So we saw in the primitive types video that type of allows us to check the type of something, right? So we want to see if the type of something is an object. In this case, null is fine to be included. So we're going to say if type of the value is equal to object, right? Then we know that we're looking at a nested object. This is the case where we're seeing a nested object. Okay. Then we're going to add an else. Technically, we don't need an else in this case because we're going to use a return, but let's just go with an else for now. And in the else case, that this is a primitive type value. Okay. Now in the case of function, that's not really true, which we'll see in a second, but that's good enough for now. So I'll just say non-object type of value is probably more accurate. So what do we want to do if we do see an object? Well, the same thing, right? We're going to assume that our function knows how to solve this flattening. So I'm going to create a variable I'll call flattened. And I'll say I'm going to call flatten on this value this time. Okay, so I'm going to assume that this is going to give me back a flattened object. Okay, and then I'm going to store that as an object inside of flattened. So flattened is going to be an object that's the flattened version of all of the nesting inside of this one. Okay, so even if value had nesting inside of it, like in the case of down here, if I scroll down a little bit, you can see I have friend, and this will be the whole value. Technically, friend has friend inside of it, which is also nested inside of it. Okay, so that is going to be included because this is recursive, which we'll see in a second. So you can think of us giving the friend as the value in this case, as an entire object that is nested. Well, if we assume that this object is not nested, what can we do? Well, we can add all the keys and values to result, and then as long as we're not adding things that are nested objects, we're good. So we know this is not nested. I just said that. I'm going to assume that that's the case. So how do we add all the keys and values from one object into another? Well, there's a few ways to do that. I'm just going to go with the easiest way, which is result is equal to spreading everything inside of result and then spreading everything inside of flattened. This is the spread operator. We looked at this in the spread syntax video. If you need a recap on that, definitely check that out. But this is saying take all the keys and values inside of result, put it back in itself, all the keys and values inside of flattened, and also put it back in its inside of result. And we're going to have a combination of these inside of the result object. Okay, so if we do this, then what we can do is this is technically a base case. We can return this result. Okay, we want to stop here and actually return out so that we can give this object that we've constructed back to whoever called us, because we have created this unnested object. Okay, so let's take a look at this. So if I run this node exercise 3, now this is actually starting to look pretty good, right? If we take a look at this, we can see that we have, this is the first object, which is right here. Our second object is happy of true, and then friend ID 2, and then name 2 and happy 2. So that's pretty good. And then over here, We have this object, which is even more nested. That's the one with Alice and oof, which is this one right here. And then look at this. We even have something as complex as this one, which is getting crazy, which has an array inside of it. It's got a function inside of it. It even has null, undefined, and a few other things. So if we look at this one, you can see that the array keys actually get put out of this and put back into the first level object. Okay. Now I believe I put a delete operator in here just to be extra sure. I guess technically looking at this, I don't actually need it. But what I did is I used the delete operator to make sure that there is no duplicates like this before trying to put it into the nested object. But now looking at this, not actually sure if I really need this. I'm just saying before I return the copied object that I've created to a level above me when I unwind this recursion, I want to make sure that I delete the key originally from here and the value pair that was in here. But I don't actually think we need this. So maybe you can ignore that for now. So if we look at this, this is actually the solution, right? Which is kind of wild, right? Like, how is this even possible? The same thing as with the array example. If we actually trace this code, if you follow calling this for this inner friend object, what you'll actually see is if you run that and come back in here, you'll actually end up returning an object that's flattened. And then in here, we're flattening it again. And then we're actually going to be able to, in this case, add every single result key and value to that object. Okay. So very, very powerful. I really can't emphasize enough. This is ultra confusing until you actually write it out. Even me looking at this code, even though I wrote this code, this looks kind of crazy, right? There's just so much happening and it's not immediately clear what we're solving until you realize kind of the context of the problem and what we're trying to solve. Then this code makes more sense. This is actually not very much code to actually do this if you really think about the complexity of what we need to deal with. Like if you look at this example down here, how on earth could we do this with loops and functions by themselves without recursion, right? Any of these could be nested to any level and we would have to be able to handle every single possible case, which is just impossible unless we have a solution that can actually wind up and then unwind itself again for every single kind of branch, I guess, of this tree. Okay, so I'm going to show you the bonus next. And just as a kind of word of warning here for the bonus, this one is really challenging, right? It's a bonus for a reason. These ones we looked at were already challenging. They probably will take you a while or took you a while to build, right? I want to show you practical examples and practical exercises for recursion and not your typical like Fibonacci example, for example, right? So just keep that in mind as you look at this. You're probably thinking, oh my gosh, like this is just too next level. Like I don't even want to attempt this, right? But if you try to like open your mind a little bit and approach it kind of gently and slowly, you may not be able to solve it, but just even following along and seeing what's happening and try to understand piece by piece is going to make a huge difference as you see this next example. All right, so here we go. So this is the bonus. Okay, I'm going to give myself some room here just because this is quite crazy. I'm going to give you an object. So just as a heads up, this is the object I'm going to give you. So go to the GitHub repo if you want to copy this or pull it down from Git yourself, or you can just type this out and I'll pause, or you can pause the video and type this out and I'll kind of scroll through this object just so we can take a look. But I'm going to give you this object, okay? In this case, I'm naming it document to simulate what's called the DOM in the browser, which we're going to look at in future videos. This is actually very similar to what the actual DOM in the browser looks like when it comes to keys and values. It just has way more keys and values, which we don't actually need for this example. Okay, so I tried to simulate the names of the keys and values and the properties just so that we have something very, very realistic. Now, the goal of this exercise is to try to reconstruct the HTML for this web page given this object. All right. So after your head explodes and you pick it off the ground a little bit, let's take a look at this. We have a document. This document has child nodes. This is an array. Okay, this is an array of what are called nodes in the browser kind of HTML world. Okay, each of these nodes can have a node name. It can have another property, which I'll show in a second, but it can also have further child nodes itself, right? So if you think about HTML, if you've seen it before, all HTML has nodes inside of it to some degree. So let me just pull up my browser real quick. I'm even just gonna pull up the Stack Overflow page, okay? It doesn't actually really matter. Just pull up any website. It doesn't actually matter which website you're looking at, even something like Google. Right click on the page somewhere in Chrome or whichever browser you're using. And if you look at the inspect button, which is on the bottom, you'll get this window on the right-hand side. It should default to this tab, which is the Elements tab. And I'm gonna zoom in on this a little bit more. And what we'll see in the Elements tab is a bunch of HTML. So let me just kind of minimize this just so that we can really see what's happening in here. This is the HTML code for this entire website. So you can see I have HTML, I have script, I have head, and then I have body. Okay. If I open up body, for example, you can see that this body is made up of many different elements. Okay. There's a header. And we're going to do this more when we get to the front end together in a separate course. But for now, I just want to give you an overview of what we're actually building so it makes sense. All of these can have further elements inside of them. You can see as I open these, they all have elements inside of them. Eventually, they're going to have no more elements inside of them, and they're going to end, for example, with something like this. Okay. So what we can say is the body has a bunch of child nodes. One of them might be header in this example. That has a bunch of child nodes. One of them is a div. Then one of them is an A tag. Then in this case, it has a span tag inside of it. This span tag though has no child nodes. It's done. We've reached the bottom of the tree for this kind of part of the node tree, of the DOM tree is what it's called. Okay, so if I come back here to my VS Code, what you'll see is that we've actually recreated that, but inside an object in JavaScript. Okay, so what the DOM really is this basically recreated to simulate or to help us reconstruct the HTML for the page. Okay, and we'll see that in future videos, but for now, just think of it like that. So each of these has a name, and it can optionally have further child nodes itself, right? Eventually, when we get to the bottom of one of these branches, we can have a node that might have something called an inner text. Now, what this is the things in between the angle brackets. So for example, let me see if I can find some in here. So maybe I'll look at this text, or look at the answer that we looked at right here. So if I right click and I inspect, so I'm gonna right click on this answer right here and click on inspect. You can see that this is a P tag, and inside of the P tag, we have a code tag, and then kind of some other things, right? So you could say that this code tag right here has some inner text, which is this type of string right here. Okay, this entire string in here, in between these start and end code tags, right? I'll zoom in a little bit more for you. This entire string in between here is actually the inner text. Okay, and we've reached the bottom of the tree in the case of my example. Okay, I've simplified what the DOM looks like to some degree just to make this recursion a little bit easier. So the goal of this is once we've reached a node that has inner text, we're at the bottom of the tree and we can close off that tag, and that's the end or the base case for that part of the recursion. So having inner text is the base case. Not having inner text is not the base case. We still have to continue recursing until we hit something that has inner text inside of it. Okay, definitely a limitation because we have tags sometimes that don't have inner text inside of them. But for now, just to keep things simple, we'll go with that. So we have a document that has child nodes, which is an array, HTML, head, script, body, UL, LI, B tag, more LIs, a div, H1, and a P tag. Okay, this is a lot of nesting, as you can see, with all the colored brackets that I have over here. Okay, now this object is available on GitHub, as I mentioned, just so you don't have to copy all of this crazy nesting. So we're going to pass this object to our function, and it's going to generate HTML for us. That's the goal. Okay, so let's kind of walk through this. When I create a function called construct DOM, that takes a single object as its argument. So that object is going to be that one I just showed you. The object passed in simulates a simple DOM object from the browser, right, which we looked at. Each node inside of there, inside the child nodes, has three possible properties. It can have a child nodes property, which is going to be an array of further nodes that are children of this parent node. It can have a node name, which is going to be a string. So for example, a p tag or a div tag or an h1 or something like that. It can also have some inner text. Inner text is also a string, which is the content in between the tag. So if it's a p tag, it's the paragraph text itself. And for this particular example, we can assume that if it has an inner text, this is the base case. Okay, this is the base case right here. Okay, so we want to use recursion to reconstruct the HTML in the correct order given this DOM object that's passed in and all the children inside of it. So again, we can assume if a node has inner text that it's a child node, which means no further child nodes under it, right? So it's the base case. We can also assume that all the tags have a start and an end tag. So there are some tags in HTML that don't have a start and end tag, but for now I've used the ones that do. So for example, we'll always have a start tag like this p tag, and then always have an end tag like this p tag. And the end tag is just a node name. So the tags are always a node name with angle brackets, and the end tag is the one that has a slash before the tag name. Okay, now don't worry about indentation and spacing when you actually make this string. The result string should all be one line. It should all be one gigantic string with no spaces in it, okay? Trying to make this work with spaces is actually quite complicated and would require a lot more work when it comes to the recursion, and would actually detract from actually trying to figure out the basic example, which is what we're trying to go through together. Definitely possible with recursion, and that's how it works. However, we're going to work with the simpler example first, and then you can try that if you want as an even further bonus exercise. So if we call construct DOM with that document object that I showed you, right? Again, this is on one line. I just put it on multiple lines so we can actually see what this looks like as HTML, so it's easier for us as humans to read. We should get a string that looks like this, okay? The HTML, it's going to wrap the head. Inside the head, we have the script with the console log inside of it. Then we have the body. Inside the body, we have a UL, which has a bunch of LIs, and two of these LIs have text in it directly. One of them has some bold text inside of it. And then we have a div as a second element in the body that has an H1, and then it has a paragraph tag. Okay, you can see the closing tags are all over here. However, there's also closing tags over here as well. Now, as I mentioned before, you're probably looking at this and being like, what on earth are you talking about, Nader? How is this even possible? Like, how do we even get here? What are you even talking about, right? Now, that's a common reaction, but I want you to think that when you see recursion, right, it's actually not as tricky as it seems, because the amount of code that you're writing is much less because you're solving for only really the base cases. We want to be able to figure out what is kind of the essence of this problem, and then we're going to use recursion to help us figure out all of these complicated scenarios where we have nesting and nesting and nesting. Okay, so give that a stab yourself. Definitely very challenging. And once you're done, take a look and unpause the video, and we'll take a look at a possible solution together. Okay, so let's get started with this one. So I'm going to come down here, and I'm going to, below my document here, I'm going to call const construct DOM. And this is going to be a function that takes a node, and it's going to do something. Okay, I'm just going to copy what I had here, which is this. So I'm going to call construct DOM. I'm going to give it my document, which is this one right here, which is this gigantic object. You can see there's a lot of lines of code in between here, and we want it to print out this HTML string right here. Okay, now, where do we even begin? Let's look at this document. So we can see that the first thing inside the document is the child nodes. So what do we want to do with child nodes? Well, what child nodes is a array of nodes, right? So we need to figure out, can we solve this problem for one node and then use that solution to solve it for pretty much every other node, right? So let's think about what the base case is in this case, right? And I gave you a hint earlier. I mentioned that the base case is something that has an inner text. So in this case, we know that if this has an inner text, for example, right? This is one example right here. This is another example right here, right? I can confidently say, given this example, that we can no longer go through any more child nodes once we see this inner text property on one of these node objects. Okay, so let's code that out. So we're gonna say, if the node has an inner text property, right? If inner text is not undefined, well, what do we want to do? Well, for now, I'm just going to return that text. I'm going to use it later because I want to put it inside of some tags. We could probably make the tag here, but for now, I'm just going to return the text directly. So I'm going to return node.innerText. Okay, so if it has some text, we're at the base case. We have a return. We're not going to infinitely recurse as long as we hit something that has inner text eventually, right? So this is when we would return. This is when we would return right here, etc. Okay, so what about the cases where there's no inner text? What about the cases where there is a child nodes, right? So what do we want to do with child nodes? Well, child nodes means that there's more than one node potentially, or one or more nodes that are children of this node. So I want to loop through the child nodes and then do something with each of those elements or each of those nodes. Okay, so then I'm going to say for const child node of node.child nodes, plural. So I'm going to loop through all of the child nodes that are inside of this array of child nodes for the current node that I'm looking at. And I'm only going to get here if the node doesn't have an inner text. So if I'm not at the end, or I'm not at the leaf property, then I know that I don't have an inner text, and I can actually get into this loop to keep on recursing, hopefully, right? So what do we need to actually figure out here? And I should probably kind of preface this by, I've already done this myself. So I've already kind of seen some of the kind of funky, weird bugs that can pop up doing this in different ways. I want to show you a correct solution that I arrived at after a couple of tries. And I don't want to spend too much time going through kind of all the cases that I tried. So I want you to know that I didn't come up with a perfect solution right away. Okay, I had to kind of move some things around just to make this work, and don't feel like, you know, oh my gosh, you know, he was able to kind of blitz through this without even thinking about it. I have my notes here on my other screen, and I already coded this out previously after a couple of tries. Granted, it didn't take that long because I was the one constructing this exercise for you, but it should take a very long time for someone who's never done this before. Okay. So let's think about this. If we don't have an inner text, well, I want to be able to kind of create these tags and start nesting them inside of each other. So I'm going to create an HTML variable. I'm going to start it as an empty string. And what I want to do is start concatenating to the string as I'm recursing through this tree structure of the child nodes. Okay. So what's the first thing I want to do? Well, if I'm looking at a child node, so like let's say I'm looking at this div, okay? So I have this object, for example, right here. Like let's just take this object, which is the bottom one inside of my DOM. Okay, the very, very last div that has an H1 and a P tag in it. What do I want to do with this? Well, this needs to give me effectively this, right? I want to create div. I want to close the div, right? And then I want to create an H1, and I want to close the H1, but I want to put my blog inside of here. I want to put my blog, right? And then after this H1, so not as a child of it, but right beside it, I want to put a P tag that says, welcome to my blog. So I'm going to copy that text right there so you don't have to watch me type it out. This is a P tag, welcome to my blog, close the P tag. Okay, there's no quotes there. right? So this is what I want to get if I come into here. So I want my HTML variable to contain this so that I can put it inside of where it needs to be in a larger context of itself. Okay, now the base cases here we've already solved, right? The inner text we've returned for this one and for this one. Now, arguably we didn't wrap it with a p tag yet or an h1 tag, but we'll do that right now. So what do we want to do for each of these nodes? Well, I want to be able to grab the node name and create a start tag and an end tag. I need to create this div. Then I need to kind of figure out this part in the middle. Then I need to create this div. So I have to create kind of the starter and the ender, and then everything in between just kind of goes in there. Okay, so I want to create this. I want to say HTML. I'm going to add to it the start tag. So I can create a template string, and this is going to be the child node that we're looking at, which is this object. So we're going to pretend that this is the child node right here. So I'm going to say child node dot node name, right? Okay, so that's the start tag. Then we're going to have to figure out how to add the inside text slash HTML in between the tags. So we got to figure that part out. And then we also want to add the end tag. So I'm going to copy that line and I'm going to say, just add a slash there to finish off this. So what this is going to do for us in the case of the div is this is going to create this part. What this is going to do in the case of the div is this is going to create this part. And then we need to figure out how to add everything in between next, which is the actual recursive example. Okay, so here is where it's kind of crazy. If you think about this, let's say that we have this case right here. Okay, this base case of a p tag. What would happen if we called it with just this p tag? Well, we would actually return just the text inside of it. So this is a bit confusing. But let's think about what would happen if we were to actually come inside of this loop and then give this as a child. So for example, what I want to do is I want to say HTML, we want to add to it calling construct DOM with this child node right in here. Okay, so if I pass to this function the child node, it's going to be we're going to be looping through each of these nodes right here. I guess this is where it gets really confusing. So I'm going to just pretend, actually, I'm going to step one step back. I'm going to step back to this div. Okay, if I give this div as node, does this div have an inner text? No, it doesn't have an inner text. Okay, so I'm going to create HTML. And then HTML is going to start as an empty string. Then I'm going to say loop through all of the child nodes of this div. Right? So I'm going to go through each of these child nodes. There's two in here. There's these two objects. Okay. So I'm going to go first time the child node is going to be this one right here. So I'm going to say, take the HTML and add to it the node or child node dot node name. So I'm going to add to it an H1. Okay. So I'm going to add to it an H1. Then I'm going to say, construct the DOM with this node. So call the function recursively with the node kind of that you're on yourself. So if I call this with this node right here, what I'm going to get is this base case, right? I'm going to see that there's inner text, and I'm just going to return that inner text right away. So I'm actually just going to return my blog, right? So I'm then going to get my blog in the case of this one, right? Then I'm going to say child node.node name, but as an ending tag, and this is going to be the end H1. All right, so at the end of this call, I'm going to have H1, I'm going to have my blog, and I'm going to have end H1. That's going to be HTML, right? And then we're going to loop through this and add that for every single child node. So the same thing is going to happen for the P, and if we had more of these, the same thing would happen for those. Now, that is really where the recursive solution actually comes in. And I want to show you that just what we have so far, even just these steps, And at the very end, I just need to return the HTML, right? Even just these steps, let's take a look at what we get. I'm going to run node bonus exercise and look at that, right? That is just totally wild. I know that even when I was creating this for all of us who work through, I was like, this would be really cool to actually build. And then I was just like hacking this thing together really quick. And even when I saw the solution after a couple of bugs on my first couple of tries, I was just wowed. I was just like, I forgot how like amazing this feels to have these recursive solutions come together, even with the other examples, but especially with the more complex examples. This is definitely up there in the complexity, but like, look at this, right? What we have built is something that can reconstruct an entire DOM object in HTML with some limitations, right? So inner text has to be kind of the base case and all that kind of stuff. But this is very, very similar, minus those limitations, to the actual DOM in the browser. So what the browser is really doing is effectively back and forth between these two concepts all the time for us, every time we load web pages. So there's a bunch of recursive code in there that's doing exactly this. Now, granted, definitely more cases to consider, more base cases, edge cases, all that kind of stuff. But it really is just a tree structure if you think about it, with nesting and nesting and nesting. And we just want to be able to flatten it out into a bunch of HTML as a string like this. Okay. Now, I encourage you to play around with this. Try to think of how you can change things around in here and do some logging in here to see things as you go. Try to add more nodes in here. Try to figure out what would happen if something had an inner text, but it wasn't a leaf, for example, or the end node inside of one of these branches. There's a lot of things that you can do to build on this. And then of course, there's the indentation, which is definitely quite complex to add on top of this if you want even more of a challenge. Now, that was a lot. I know that these exercises were very, very hard. Okay. So I just want to kind of wrap this up by saying, if you were able to even attempt these and even start it and get partway through, I'm proud of you, honestly. Like, these are very, very challenging. These are the kinds of things that might come up in very high level interviews. I would not expect someone to answer these questions in like a junior interview, for example, depending on the company, of course. But generally speaking, this is something that takes a bit of experience and time to really wrap your head around, to really understand what is happening and to come up solutions like this, come up with solutions like this. But once you do, once you get that practice and once you see it working, it's like a bug. It gets stuck with you, right? And you're just like, oh, I want to try that again. This is beautiful. And you start to think about where this happens in the real world in many different cases. If you think of JSON, for example, JSON parse and stringify, this is what's happening. If you think of the DOM, this is what's happening. React, it uses this behind the scenes, right? So many things in the world that we use when it comes to programming as developers use recursion. And they are truly beautiful solutions and very concise when it comes to the code, because everything boils down to just a series of different base cases that we need to solve for. All right, so enough of me waxing on recursion. I hope you enjoyed that. What we'll do in the next video is we're going to go over a brand new concept also on the intermediate or advanced level that's called closures and scope. I have a whole bunch of fun drawings and analogies to go through on that one as well, since this is a pretty important topic in JavaScript. But I hope you enjoyed this video. If you did, I'd love it if you could like the video and subscribe to the channel. I'd love to hear in the comments how you thought of these recursive exercises. Were they too hard? Were they too easy? I'd be surprised if they were too easy. Do you want more of these exercises and more practice? Do you still not really feel like you're getting enough practice? Do you want more examples or simpler examples? Just let me know. And we have the Discord server as well, where you can join to ask questions if you're interested. So I'll see you in the scope and closures video once you have a chance to take a look at this. I'll see you later.